In this video we are going to demonstrate a timer boundary event. Consider a claims and complaints process. One of the most important parts is to perform the actions and inform the results. This activity is executed when the claim is successful. In the claims and complaints process, having analyzed the claim, a period of time is defined to perform the necessary actions and inform the client. If the actions have not been performed by this time, the immediate supervisor will perform a control and decide whether the task should be reassigned and a certain time should be defined again to perform the actions, or the claim should be filed and a reason should be documented. How do we control the time related to this activity? In this model, an additional database exclusive gateway has been included to control the maximum time associated with the perform actions and inform result activity. Is this model okay? Imagine some scenarios. The assigned person finalizes the activity within the time established. As the time has not been exceeded, when the condition associated to this new gateway is evaluated, the process flow will go back to the same activity. This is not logical. If the assigned person does not finalize the activity within the time established, no action will be triggered. Only when the activity is completed will the condition that tries to control the maximum time be evaluated. This is not correct, as the control will be executed too late. This is not the way to control this situation. The timer intermediate event can be attached to the activity's boundary. Consider the following process flow. In this case, the B activity should be performed within a certain time. Otherwise, an exception path should be activated. If the activity is completed within the time configured in the timer, the process flow continues with the C activity, the normal flow. If the activity is not completed within this time, an exception flow is launched. The exception flow is the D activity. The B activity is cancelled, interrupted, when the time defined is met, and the exception flow is launched, flow path that starts from the timer boundary event. A timer intermediate event can be drawn in sequence flows which represents a delay or wait. For example, the B activity will be executed after the A activity and a delay. Also, a timer can be drawn attached to the boundary's activities which represents an exception, timeout, that will be launched when the time is met. In this example, if the actions have not been performed by this time, the immediate supervisor will perform a control. To model this exception, a timer attached to the boundary of the perform actions and inform result activity will be included. The exception path is the control implementation of actions activity. The normal flow is to finish this critical activity within the time and finalize the process flow. Finally, compare the following two diagrams. Are they the same? See the simulation. In the first diagram, if the B activity is performed within a certain time, configured in the timer attached, the normal flow is executed, i.e. the C activity. Otherwise, the B activity is interrupted and the D activity is activated. In the second diagram, the B activity and the timer are enabled. If the B activity is executed, the timer is deactivated, and therefore this path in the process flow continues. On the other hand, if the time is met, the B activity is interrupted, and therefore this path is disabled. In conclusion, these two diagrams are equivalent.